Hello and welcome to the new video, and in this video we will going to understand what is bias variance trade-off. So bias variance trade-off is the base of every machine learning algorithm that you will going to use, and that's why it is very important to understand this core concept, because even in an interview you may face a situation where interviewer may ask you about the bias variance and what is the trade-off that you need to do. And in this video we will going to look at both bias and variance, and not only this, we will look at the topics like overfitting and underfitting because they are closely related to this, and then finally we will make some conclusion to help you understand how you need to choose between what should be the bias, what should be the variance, and then how you need to do the trade-off. So let's go ahead and start understanding this. Alright, so what is bias? Well, in theory, when we create a machine learning model, we need to accept the level of bias in algorithm so that it can cover most of the data points. Let's understand this with a visual. So what do I have over here is two-dimension chart which represents on the y-axis you have sale, on the x-axis you have expense. So expense is nothing but the marketing expense, and generally the assumption is that if you have more marketing expense you have the higher sales numbers. So these are the data points which represents the same assumption. Now, if we need to identify what will be the sale at a particular level of marketing expense or a particular point of marketing expense, we need to fit an algorithm so that we can do the prediction. Now, since these lines or these data points represents the linear trend, it is a good candidate for linear equation or a OLS, which is ordinary least square method. Now to fit it, what I will show you is basically some comparison between the line to help us understand the bias. Now whether this line truly represents all the data points, or this line truly represents all the data points, or this line truly represents the data points. Pause the video for a minute and just try to understand this chart. So I hope by now you have understood this chart, but if not, what we are really trying to understand over here is that we have these 5 different data points and we need to figure it out which line is best representing all these 5 data points. And by now you must have figured it out by looking at visually that the line here in the center is representing it best. Why? Because from this line the distance between each of the data points is less. For example, if you have only this line, so if I just go 2 steps back, if I only have this line, the distance from this line to this data point is high. Distance from this data point is high. Distance from line to this data point is low, and finally the distance from this line to this data point is high. So there are a lot of data points, for example these 3 data points, which are relatively far from the line. Now let's say if we have tuned the parameters and created a new model which is seeing that based on these 3 data points that you have available, the new function is fitting the line like this. But even in this case, we have some of these data points, which is these 2 data points, which are very far from this line. Now again, we further tune the parameter values, or we further fit the model on the training data, and we figured it out that this line is the new line, which is reducing the distance between the data points. And finally we say, yeah, this line really represents or truly represents all the data points. Now this is basically what we called is basically a bias. So bias is nothing but you have all these distances from the line, and we need to reduce the bias by having the best fit line or the best fit model, which is having the representation of all the data points with the minimum bias. Alright. Now, apart from this, one can even have a model like this. So what do we have is basically a non-linear model. You can use the non-linear function or non-linear modeling approaches, which will try to fit all of these data points all very perfectly. But this is something which is called as overfitting, and the reason for this is that though it will work well when it comes to training the data, but when it will see the new data points to make the prediction, it performs very bad. So we try to avoid the situation where we are trying to learn each and every data point from the training data very accurately. In that way, you are having a very high influence of training data on your model, which may not result into a good prediction on the unseen or the test data. So let's go ahead and now understand the variance. So what is variance? Variance is nothing but the difference between the fit of training and testing set. So let's say what I have over here is basically what I showed you in the previous slide, the best model, which is representing the data points, and then this overfitted model, which is trying to capture most out of the training points. And let's see how well they fare on the unseen data or the testing data. So what do we have is basically these three data points, which is the testing data points. And over here from this line, you can see that there is this line will do a better job in terms of predicting it. And after the prediction, it has plotted the data points over here. And then we calculate the variance for these three data points. Now, if you have the same data points over here, you will see that in one of these odd cases, it will work fine. But if you see this data point, in this case, the distance is pretty high, and same is the case with this. In this case, the distance will be pretty high. So that's why this overfitting method or this overfitting technique will not going to work in most of the scenarios where you have almost negligible variance. There has to be some variance, some bias, which is a true representation of all the data points, and we should accept that bias so that whenever we are showing the unseen data points like these three green data points, then our model should be able to predict and have the low variance even in that case as well. So finally, what is the conclusion? Conclusion is that a good algorithm will have a low bias and should be able to model the true pattern from data. Algorithm should be able to predict the new values consistently with low variability. That means the low variance. So your algorithm should have low bias and low variance, and that's what my next point is related to, that there are multiple iterations you may need to do by tuning the parameters or by changing the algorithms, and you need to see where you are getting that sweet spot which is having the low bias and variance. And finally, the fourth point is some of the commonly used technique for finding the best model are regularization, and this is basically what I wanted to say is boosting, but I think I misspelled it. So boosting and bagging. So in the future videos, I will explain you about this, and one of the video related to regularization I have already posted previously, so you can watch that. It is related to the ridge regression, and couple of other videos related to regularization and boosting and bagging I will post it in the future so that you can help understand those concepts as well. So let me know how you find this video and what concept you would really like to learn, and I will try to create a video on that. Thank you for watching.